our document for how we're gonna map our data into the common data model. We created our code mappings, including those ones we did on our own with Usagi. We then talked a bit through implementation, but of course this is going to vary by site. And we can, if you have some more questions about that, feel free to contact us offline if you want to talk through that. But now let's talk a little bit about quality control, because once we get into this this cycle here, once you've built your ETL, it's kind of like a constant cycle of quality, build, implement, error checking, all those kinds of things. So it's a constant maintenance cycle. Once it's done, it's not really done. You just move away from the initial build into maintenance mode. So let's talk a little bit about quality control and how that looks and what's available. So we have a couple different things. We have something that's called the test case framework. So it's actually, our little rabbit comes back again. Rabbit in a hat does something for us where it helps us build a unit test case framework. And I'll show you, walk you through how that works. It does, it is an R function, and it's in the book of OHDSI as well. So I'll give you an example of how that works. We're also going to talk about Achilles. Achilles is a really great characterization tool. So it goes through your database and it looks at all of your tables, all of your fields, and it runs a lot of different characterizations on every single concept ID in your database and almost every single person in your database. So it's a really, really powerful characterization tool. And then, of course, my little baby I shared yesterday, my data quality dashboard, or as we like to call it, the DQD, for those in the know. And now you're in the know. Okay, so the first thing we're going to talk about is unit test cases. So this is a little bit different than something like Achilles or DQD that runs on your full CDM once it's done. So what the unit test cases do is it's this framework built into Rabbit in a Hat, and it helps you create like this really small little test database that looks just like your source database. It's just really, really small. And each little unit test case you write is written so as to test a piece of logic in your ETL document. So for example, in our commercial claims and encounters database, it's 150 million people, as I've been saying. Our unit test database has, I think, like 50 people, maybe less. So it's really, really small. And what this allows you to do is you can quickly run your builder on this really small set of data. And each little piece of that database, because it's testing a piece of logic in your builder, it really helps you identify any issues in your builder up front. So it's a really nice iterative process. You could run your builder really fast over this really tiny little database so that you can identify those issues and quickly fix them before you deploy it to your main database, and you have to wait days or for us sometimes weeks in the old days to get that done. So this is really nice. And Rabbit in a Hat does this for you. So how this works, I'm not going to open it up because I think you can kind of get the gist of how it looks here. But you just go into Rabbit in a Hat after you've loaded in your White Rabbit scan, and you just click Generate ETL Test Framework. I know it's a little hard to see here, but it's File, Generate ETL Test Framework. And what this outputs for you is one R file that if you put it into RStudio and you source it, it'll create a bunch of different functions that you can then use to build your little test database. So here's an example. We have our little framework.r. I'm going to source it to get all those functions out. And what it does, it creates functions for each table in your database. So in this example, I have an enrollment table. So it's going to create a function called add_enrollment. And then what I can do is I can pass in some values for a member ID or a gender. And then it's going to create for me an insert SQL statement that will insert directly into an empty source database. So all you have to do, essentially just pass it a few values, it'll handle the rest and generate this insert SQL statement. So as you scale this up and you maybe create a few more, you end up with this nice little SQL statement of just inserts that'll create this test database for you. And what you can also do is it also creates some expect functions. There's going to be an expect for every CDM table out there. And what you can say is like, if I see this person ID 102, I expect them to have gender 8507. And so with these expect functions, this is going to create another SQL file that comes out called like test.sql. So what you do is you run your insert, you run your builder on that like little tiny database, and then you run this test SQL function. And then what it's going to do is going to say, am I seeing those values that I expected to see if my builder was running correctly? And this is just a nice little schematic of how this all works together. So we've got our scan report, we've got our CDM specifications all falling into Rabbit in a Hat. Rabbit in a Hat generates our test framework, and then our unit tests generate our SQL to run those tests, our SQL to generate the test data. And then you can see how those two DBs kind of work together and comes out with your little test results. So you end up at the end with like a table that tells you for every unit test case you created, does it pass or fail? So I did this for Cynthia. I'm just going to show you just a quick example of how this looks on the VM. And I didn't want to go into the R code because I know it's a lot of just kind of in the weeds with that. But I really quick want to show you, because you've probably noticed in our ETL database, there's a lot of other schemas in there. So if you look for CDM Cynthia test, this is going to be that test database I'm talking about. So every person and record that I've generated in this test database, like, kind of has something wrong with them, or at least they should have something wrong with them. And then what comes forward should be passing based on the logic that I gave to my builder. And as an example of that test table, I think I have it here. It's called test results. So I'm just going to do a quick select to show you. And feel free to follow along with me, you guys, if you want. That's why I put this out here, so you guys could play with it. So CDM Cynthia test.test results. I'm going to hit F5. So here's how that looks. And here's like my nice little passes. And I've got some fails in there, but most of them pass. And so what I would then do is because it's so small and I have these like different little unit test cases, I could go and find each individual record that I created that has failed, and then I could go look and say, okay, why is my builder not doing what I think it should be doing? And most of the time when we've done this, it's really just coding mismatching. So I look up a code wrong in the vocab, and so I expect an ICD-10 to map one way, and it maps to a different SNOMED, and so then it fails. And so usually that's where our fails come from, or I tell my developer, hey, I told you to do this, and he goes, hey, I did do that. You just wrote it wrong in your test case. And I always say, oh, my bad. I knew that. Just making sure you knew it too. So that's mostly what happens for me, at least, is that I write my test case wrong, and then I just have to go back and fix it. So it actually really helps you to understand your source data and understand the logic that you're implementing by using this test case framework. And if you want to explore this a little bit, you can. So this whole database is pretty small, but it has all those test cases in there. And the way I did it is this ID field here usually is the person ID, but I put a little note at the end because you can annotate these. So I put a little note to let myself know what does that ID field actually mean, so that I can go back and check through it and try to figure out where my errors are. So here's just an example of how we might test it for the person table. So how could we create a test to make sure that my genders are being mapped properly? And then here's how I did that using that R package. So I'm saying add patient. So our framework R file created that function add underscore patient. So for every table in your source, you're going to get a function like that, add underscore table. And then I'm creating a patient ID, and I'm giving it a null gender. And then what I'm saying is I expect there to be no person in my CDM that has this patient ID. And it's pretty straightforward. And then what happens is once I put them all together and I tell it, okay, create me that SQL file, it's going to create this really hard to read little SQL insert statement here. And you see a bunch of other values in there that I did not specify. God, I'm sorry guys, I keep hitting that. That I did not specify. And what happens is as it reads in your scan and it generates the test framework, it uses some default values that it sets out of your out of that scan report. So you can change them if you want. It's just kind of interesting how it does that and how it all works. It's pretty robust. Again, built by Martijn. Okay, so let's move a little bit into Achilles now. I think Achilles is one of those things that's actually really useful, and it's actually really fun to play in it. So it's basically for data characterization, and it does have, of course, some quality baked in there. And I did include the script I ran to get the Achilles data out of our CDM Cynthia database, because it does require, it is another R call, but it's pretty simple. You can see in the materials there if you wanted to run it yourself. And it just creates some JSON objects that then the Achilles, there's an Achilles web application, reads those JSON objects and then exposes that information for you. So let's take a quick look at Achilles. So most of what I wanted to do with data quality is kind of move back and forth between our slides. So just using the slides is okay, yeah, let's go to Achilles now. So if you want to move over to the VM, feel free to do so. All right, so when you open up Google Chrome, it should have, it should open up directly to your localhost Atlas instance. But what I'm going to do is I'm going to navigate to localhost/Achilles. And this nice little dashboard shows up. So there's a couple, we haven't talked about SynPuff today because we're not using it, but there's a couple different databases on this box, SynPuff being one of them with 100,000 people. But what's nice about Achilles is that you can have multiple different data sources in here. So I'm going to navigate to CDM Cynthia version 1. So that's what we're talking about right now. And you see we have our 1,000 people, about half and half female and male. And that's just an overview. And then we can click through some of the reports. So like I said, there's a nice report on person. So we can see the breakout by race, by ethnicity, by year of birth. What I really like about Achilles are some of these event table reports. So when you click on condition, it comes up with the tree map, but I like to go into the table. And then what's really cool about it, and you see these NAs here just as a side note, it's just because I didn't build one of the tables that takes forever to build to find the tree that these concepts fall in, because it was just gonna really eat up the space on our box. But when you do this for real, you would actually build that one table. I think it's called concept hierarchy. So I didn't do that, so it doesn't normally say NA, but I didn't want us to have no space on the box. So for example, if I click on otitis media, what's really, really cool is that this thing down here shows up. So it shows you the prevalence by age. And then it should show you by month, but we just don't have enough people with it. And types, if you had multiple types in there, like we talked about earlier, you could see the breakout by type, and then the age at first diagnosis. So a lot of times when we're doing a study, if we're interested in a specific condition, or I want to know how many people will I find just even with this code, a lot of times we come to Achilles first, and we'll start to investigate how many people have some of these codes. So a lot, especially with drugs, there's not a lot of people that take certain drugs. So instead of me going into Atlas and building a whole cohort, I can just come here to Achilles. So I really like it. I think it's really robust, and I think it's really nice as just a characterization tool. Okay. Any questions about Achilles? Okay, I know it's getting late in the day. All right, so we talked through the dashboard a little bit. Yeah, there's a data density plot I didn't quite show you, but what's interesting about this is like Cynthia, there was like something weird, I think, with 1961. So it'll show you like the amount of data you have like each month over time, which is kind of cool, and it can give you an example of like if there's one month that's like way up or something out here like 1961, you can take a look and be like, hey, that's really weird. Maybe we need to think about doing something with this data. Now there is an Achilles heel report. It does run a series of data quality checks. So as we mature the data quality dashboard, I'm not really sure how we're going to move forward with Achilles heel, but it does run a set of data quality checks on your data. So let's actually look at it for Cynthia real quick. We've got our CDM Cynthia version 1, and if we go into Achilles heel, yeah, you see that same thing here. And it just gives you just like some things you might want to note about your data set. So moving from Achilles, and we're thinking about Achilles heel, that's when we move into the data quality dashboard. I talked about this a little bit yesterday, but it's going to run a pre-specified set of data quality checks and thresholds on your CDM and give you kind of like an overall score. And this is actually an old version because I talked yesterday about how we have over 3,000 checks. So this is actually an old version that only had 1,600. And here's just a few examples of how those look. We have like the % of violated rows, the description of what was run, the threshold, and whether it passes or fails. So it's just another way. There's like, what I'm just trying to get at is like there's a lot of different ways you can interrogate your CDM and understand the quality of what you've done to make sure that it's doing what we've said it should be doing, and that there's nothing standing out and things that you need to address. Okay, so let's get down to the nitty-gritty. Are there issues in our synthetic data? Is there something wrong with what we've done so far? So the first place I would go is to my test cases. How do they look? So I've just highlighted one of those fails we were talking about earlier. Kind of hard to see, but there was an ICD-9 in a column. It's supposed to get a condition concept ID of 0, and it's not, so it's failing. So there's something, when I look at this, I'm like, okay, there's something weird going on with mappings here. I'm not really sure what's going on, but something's not quite right. Maybe I want to take a look at that. And we would do that. We saw this earlier when we said, we went into that test results table. So the next thing I would say is, okay, did Achilles notice anything? And one of the things down in the Achilles heel report said, there is an unmapped data over percentage threshold in condition. And that's not super informative. It does tell me that there's some unmapped data there, but I don't know what that threshold is, and I don't actually know what the percentage of unmapped data is that I have. I just know that it's something that Achilles heel is telling me like, hey, you might want to look into this. But if we look at the data quality dashboard, this one actually is a little bit more informative. So I'm actually going to go to the data quality dashboard. I did create some of these objects for us to investigate if you guys want to take a look at that with me. So we actually are going to, I wanted to do this together if you guys are interested. So we would need to open up our studio. So what I typically do is I just search for our studio. Hopefully it comes up. There we go. All right. So we're just gonna write a little function. Okay. I don't know why that's up there. So it might bring up a bunch of junk in here. You can get rid of it if you want. I don't know why that's happening. So what I would do is I would say when we're in R and we're going to use a package, we're going to say data quality dashboard. We're going to qualify it with what we want. And there's just very few functions in the data quality dashboard because we didn't want to be, overload everybody with a ton of functions. So we're going to say view DQ dashboard. We're going to choose that. And now we need to find the JSON object that this Shiny app is going to read. So I think I put it in here. in our ETL tutorial materials, if we go to Data Quality Dashboard, we have two here. So I'm actually going to choose the results CDM Cynthia v1.json. So I'm going to take that and I'm going to put this here. And then I'm going to say results CDM Cynthia v1.json, which I think is the way that we wrote that, right? Yeah, okay. And then R is a little funky. You got to use forward slashes instead of backslashes. So be sure to do that if you're going to run it. And then I just hit Control Enter. Uh-oh. I didn't like something. Oh, it needs to be qualified with quotes. And there we go. Now for those of you trying it out, were you able to bring it up? Yeah, I see some heads nodding, see some things, okay. So yeah, this one was run on the newer one. You can see over 3,000 checks. We're at 98%, I'm pretty happy with that. But I did want to draw our attention to that one mapping issue that we're seeing. So I'm actually going to search for condition occurrence. And because it's a mapping issue, I know it's a completeness problem. So I'm going to do that. And it is a fail. So I'm going to sort on failures. And that's what we see here. So I'm going to make it a little bit bigger for you guys to see. So it's the number and percent of records with a value of 0 in condition concept ID. The threshold is a 5%, and we're sitting at a 61%. So not super great, not really happy with that. So I'm actually going to take that SQL that was written. And you guys tell me if I'm going a little too fast. I'm happy to slow down or answer any questions that you have. So I'm going to take this SQL that was written. I'm actually going to take this like middle piece. Because if you take the whole thing, it's just going to return back for you that actual like percentage. So I'm going to take that middle portion that's finding me the violating rows. So I'm going to copy that. I'm going to come back to Postgres. And if you remember, we're working off of CDM Cynthia version 1. So as Erica showed us earlier, we're going to say set search path to CDM Cynthia version 1. And I'm just going to paste what I have out of the data quality dashboard. So if I run this, let's cross our fingers and hope that it works. Okay, perfect. So now what I'm finding are all the records that have a condition concept ID of 0 and what they look like in my database. So when I move across, okay, so here's my condition source values. A lot of them, I think someone asked this question earlier too, like what do you do if you have descriptions instead of codes? How do you handle that? So that's what we have here. We have no code, we just have descriptions. So if you remember what we did in our document, we were just mapping ICD-10 codes. We didn't do anything with these, so what happened was they all got mapped to 0, and now that's failing in our data quality dashboard, and that's exposing that issue for us. So what should we do from this point? What do you guys think we should do to fix this? Yeah, exactly, Usagi. So we're gonna create an Usagi set of mappings that we could then implement in our database, in our builder, to then fix this issue. So let's do that. So I'm going to quick show you. If we go back here, I did actually do this for you because I didn't think we'd have enough time to do another Usagi exercise, and you guys have already seen how it's done. But I did want to show you how it looks. Once you export that source to concept map, how does that look actually in the vocabulary table? So I think one thing Erica mentioned is every time we build a CDM, you should be saving the vocab that you use to build that CDM, you should put it in your schema. Because the vocab is often changing, the team is often updating things or adding new concepts, and so you'd want to make sure you have that snapshot of the vocab that you used in that schema that was used to build your CDM. So I'm going to cheat a little bit because I put it in the CDM Cynthia version 2 schema. So what I'm going to say is select star from CDM Cynthia version 2 dot source to concept map. And if you do this on CDM Cynthia version 1, you will see that it's empty. But if we do it in version 2, I'm going to show you here what we've done. So we did this for both conditions and drugs because it's actually an issue in the drug table as well. So this is how it looks. These are those mappings that we created using Usagi, mapping these descriptions from the source tables over to standard concepts. So this is how this looks. And then we would use that same query that we were using earlier, source to standard, and it's now going to pick up these codes, these mappings. But in order to do so, we actually need to put it into our document. So if we go back, and if we go to github.odyssey, or is it odyssey.github.io? We go back here, that's why we have this here, the Cynthia version 2. So not only do we want to version control like our actual databases, you may also want to keep a record and some version control of your documentation as well. So in version 1, we have our ICD-10-CM, but now we've included this new Usagi mapping, this new vocab that we've created. So in version 2, we would need to input that here as well, and that's what we've done. So now we've updated our documentation, we've updated our vocabulary, and then we need to update our builder. So any questions so far? Okay, great.
Basically, you just add those concepts into the main concept table?
So that's why we put it into the source to concept map table. So that query is going to pull from the main concept table, and then it's going to say, okay, what mappings exist in the source to concept map table, and it's going to pull all those together to perform those mappings. Yeah, so I wouldn't actually put concepts in the concept table. It's tricky when you start creating your own because then you could butt up against any new concepts that are being created from the vocab team. So that's why we like to do it this way. So that way you preserve those mappings, but you don't need to create any concepts because that could get a little iffy in the future. Okay, so basically then what you would do, we have our new vocab, we have our new documentation, you would then update your builder. And then what I did was I also ran Achilles again on this new version 2, and I ran the data quality dashboard on this new version 2. So we can do the same thing. So if I just go here, if I'm going to bring up CDM Cynthia version 2 data quality dashboard. Okay, so here's the new one. And we'll let it it takes a second. There we go. Right, so we're at 97%. And if we do the same thing we did before, so we search for condition, condition concept will be fine. Okay. Okay, it's telling me it's failed, but now it's down to 14%. So it's still failing based on this threshold that we've set. But we did do all that mapping and we did everything right. So this is an example where you might want to go in and say, I've done all the mappings I can. My database just doesn't have any more that I can map to a standard concept to get down underneath that 5%. And so this is an example where you could go in and you could then change that threshold to reflect what you understand and you know about your data. So if it were me, I'd probably go in and say, all right, like I've done as much as I can here. I'm going to set this threshold to a 15% because I've already investigated this issue and I've fixed it to the best of my ability at this point.
How do you change the threshold?
That's a good question. That gets us down a little bit of a rabbit hole into DQD, but I'll take a quick tangent just to show you how that would work. So what you would do, it's on GitHub. So this is the GitHub project that we've put together. And in a nutshell, the way that this works is that there are underlying CSV files that feed information into the R package. So here in inst and in CSV, we have 4 different files that actually inform the R package what to do. And so the one we're looking at is the concept IDs in the condition occurrence table. So that's actually a field level check. I didn't really go into this much yesterday, but we have different levels of checks based on how they work. That's a field level check. So what I would do is actually, I would go in here. It's gonna come up. I actually think I have it in our, in my little repos here. So I pull up the field level CSV file. And then what I would do is I would find that it's like condition concept ID and like standard concept completeness, I think. So if we look for condition concept, so it'll be on this row. So again, not to get too far in the weeds, but basically every data check type that's run on a table and field is a column, and every column has a threshold associated with it. So I would just search across this row here, and I would find that check that's being run, and I would change it from a 5 to a 15, save it, and then reload the package, and then rerun it. And then you should see that change in your final data quality dashboard to a pass instead of a fail.
Maybe an ID will help. Instead of, for example, like you have like an ID for each test,
Yeah.
and so you don't have to guess like.
Exactly. Yeah, the suggestion is adding an ID, and that's something we've thought about. So as we've done it so far, we do implement IDs when it's run. So each check gets its own ID, but it's just internal to the tool. And one of the things we're talking about is like, well, once you find an issue and you've addressed it, and maybe you change the threshold to reflect that, you know, in this exact example, like, okay, I'm changing it to 15, I've done everything I can. But I should probably also write something about what I did. And like, what do I do with that now? Because I need to tell someone else, okay, I created this Usagi mapping, I created this, you know, this vocab. So one of our thoughts is just that, like, making the IDs for each data quality check that's created more meaningful. And then once it's more meaningful, you could assign some type of like note or metadata about that data quality check that was run. So then someone who's checking behind it or looking at it in a different, or like even yourself, like coming back 6 months later, you're like, oh yeah, I created that Usagi, that Usagi mapping, and I don't have to worry about this again. So it's definitely a good suggestion. It's one we've thought about. But if you are so inclined, feel free to put an issue out on our GitHub just to remind us, like, hey, this is a good idea. But this just in a nutshell, there's a lot involved here, and of course this isn't the data quality tutorial, so I didn't want to go too far down that road, but at least give you an idea and a little taste of how this works. So So then, just as a side note, if you go into CDM Cynthia version 2, and if we set this here, so we had those violating rows before. If we do this, and we just change this to CDM Cynthia version 2, and we execute it, there are far fewer records. So I only have 500 records when I think before I had quite a bit more. So, and if you look at the source values, they look a lot different. So a lot of them are like a couple codes that didn't get mapped for whatever reason. They just didn't have a standard mapping that I could create. All right, so. All right, so this whole thing I've been talking about with our data quality dashboard, talking through how do we fix these issues, like, you know, how do we maintain our database in a way that we're identifying these issues, we're fixing them, and then we're documenting them. So one of the things I actually didn't go into, but at Janssen we have, like, many of you may know about Jira. It's like an internal ticketing process. Here we put it on GitHub, but you may, if you have a separate developer that you're working with, you may want to have some type of ticketing system or record system that you're using to keep track of those bugs, to make sure that a lot of times, like in our databases, for example, they come up more than one time. Like we run it, we fix it, and then 3 months later, somehow it crops up again. And so it's nice to have a running record of what you're doing, what issues have come up, and how you fixed them. Yeah, so we've been through all this. We created our vocabulary, and that's that portion of that query there that'll pull it out. And one thing I actually did want to mention, I thought this was really cool. I wasn't sure if it was going to work out with Cynthia, but if you actually compare the conditions in Cynthia version 1 to the conditions in Cynthia version 2, you'll see that the codes with the highest prevalence are very different between the two. So I think this is really important, and another example of how those issues will really affect the evidence you're generating. Because, for example, we started out with version 1, the highest prevalent code is acute bronchitis, where there's 442 people with acute bronchitis. But in version 2, once we fixed our mapping, now viral sinusitis is the one that's occurring most often, with over 700 people having that code. So if you're running a study on version 1, looking at viral sinusitis, and you're not finding anyone, that's really going to affect the evidence that you're generating. And you're not going to get the actual correct information that you should have gotten because you didn't have those mappings done and done correctly. So we're around our final hard lessons learned. So we're coming close to the end of our session, but before I move on, are there any outstanding questions or things you guys have been struggling with today, or just want to go over one more time? Okay, good. Looks like we've done a good job. So just a couple things that we just want to drive home a little bit. So this is what we call our 80-20 rule. You don't have to map all the terms in your data to get good data coverage. So what this is showing is the amount of data that's being mapped, and then the percentage of terms being mapped. So I think this really shows a nice way how you don't have to map all the terms to get almost 100% coverage of your data. So don't kill yourself over the last few codes that have very few records. You don't need to worry about those, it'll be okay. But you really wanna focus on those high, heavy hitting codes, which is why looking through that version 2, version 1 of CDM Cynthia, we really wanted to get those mappings done because we were missing a big chunk of our conditions. And then it would have totally thrown off any evidence that we were trying to generate. And don't be afraid of data loss. We do have some issues where we have some folks saying, I don't want to lose people, I don't want to lose people. But really you have to think about it of if a person doesn't have a gender recorded in your database, are you actually going to use them in analytics anyway? Like, how useful are they going to be to you? So if you're not going to use them in analytics, it probably doesn't make sense for you to keep them in your CDM, because your CDM is really there to facilitate the studies that you're running and to answer those questions that you're trying to get at. So if you're not going to use those people anyway, don't feel free to chuck them out. Like, they're still going to be in your source data. You can still find them if you need them, but really you probably won't need them. So don't worry too much about that if you're concerned about it. Yeah.
No, some data types that we cannot map, just but the source data you still map dump into the CDN.
Yes.
Without mapping.
Yeah, so the question is, like, some things we lose and some things we dump into the CDM without mapping, and that's a good question. So when we talk about data loss, a lot of times we talk more about removing people. So we don't necessarily, because the CDM is a person-centric model, we don't necessarily want to keep people that aren't going to help us in our standard analytics. When we're thinking about people who have source codes that could potentially help us in the future or potentially be mapped in the future, and in that case, yeah, we're going to keep them. If I have a good person that has a lot of data and they just have some things that are unmapped, I don't want to get rid of that unmapped information. That makes me uncomfortable. But when we think about people who cannot help us and move our analytics forward, I don't mind getting rid of those. Yeah, so just like another quick review of what we've gone over today. We had a lot of content, a lot of good questions. I really appreciate you all like staying engaged, staying interested. I know it's a long day, but I think this is one of the best crowds we've had, honestly, for questions and interest. Like it's been really heartening to us, because this is the second time we've run this so far, and we're really happy because I think for Erica and I, it's a topic that is really, really important to us, and we feel like it's something that really needs to be driven home as the correct process to follow. And so, of course, we love Pusheen. So you've seen Pusheen throughout the day. He's our little mascot for at least the tutorials that we're involved in. And just another reminder about all the different tools that are available to help you. So you're not on this journey alone. You're not on this process alone. There are lots of tools out there. And of course, there's always the forums and the GitHubs there to answer your questions. And you can reach out to Erica and I specifically if you have some additional things that you'd like to talk about. And just as a reminder, it's all about maintenance. So once you're done, you're not done. You just move into a different phase of your ETL. So you always want to be keeping track of what you're doing, making sure you're looking at bugs. If you have updated data coming in, you definitely want to think about how that's going to affect your builder, how that's going to affect your ETL. There's new vocabs always coming in. So just think about it as a, lovingly as, this is how it is now. I have my ETL, but I have to keep it going. I have to keep it updated so that I know the evidence I'm generating is the best quality evidence that I can put out there. And I think that's about it. We're still a little early. But we just want to say thank you. This, of course, is made possible by so many collaborators in the OHDSI community, and as well as AWS. Those are the boxes we've been using today, and James and Lee and Anthony Senna have all worked very hard up to today to get those all ready for us. And that's picture of James. And then Anthony Molinaro actually wrote the builder for CDM Cynthia. So I've been bugging him for the past few months, helping me to fix some of those different things with version 1 and version 2. And of course, our Pusheen the cat. So, so that's about it. That's about what we have. And we'll stay around for a little bit to answer any questions. But feel free to come by and chat with us before the end of the day.